Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, please know you will be able to access the webinar later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many questions as we can near the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for two $50 Amazon gift cards, so please stick around. Hopefully you'll be one of our 2 lucky winners. Okay, with that, we will kick off today's webinar, which is Effective Cost Management for Amazon EMR. Before I turn things over to Jason Beck, who's Senior Director of Product Marketing at Unravel, we do have a quick polling question that I'd like to pull out. And you can see it on your screen right now. The poll question is, what is your most challenging in managing the cost of your Amazon EMR environment? So you can choose from I don't have enough granular visibility to cloud spend, correlating metrics to a single event is a challenge, predicting cloud infrastructure capacity is trial and error, or none of the above, I'm not concerned with cost. Okay, we'll give you guys a couple more seconds to go ahead and submit your answer, and then I'll hit the close poll button and we'll show you the results. All right, great. So I'm going to go ahead and close the poll now, and let's take a look at the results real quick. Looks like the majority of you don't have enough granular visibility to cloud spend. So with that, Jason, I'm going to go ahead and turn it over to you and let you get started on your presentation.
Great, thanks, Charlene. Good morning, good afternoon, everyone. I'm Jason Beck. I am the Senior Product Marketing Manager, Senior Director of Product Marketing here at Unravel. And today, I am joined by a couple of my colleagues and also AWS. So we're joined by Jovan George, who is a Senior Partner Solution Architect at Amazon Web Services. And also we're joined by Scott Sumner, who's the Director of Solution Engineering here at Unravel Data. So we'll be covering really cost management for Amazon EMR today. And we'll start the hour with Jovan talking about big data processing with Amazon EMR. And the case to be made for running your big data clusters on Amazon EMR. And then we'll run into cost management for Amazon EMR with Unravel Data. And then we'll go through a product demonstration of Unravel for Amazon EMR with Scott Sumner. So before we really get into it, I'd like to cover just a couple minutes of the partnership that we have with AWS. So many of you know that we are a AWS partner, part of the APN Partner Network, and we're in fact an advanced technology partner, which means that we've gone through a pretty rigorous process of certification and vetting from the AWS solution architects to ensure that our solution has value with the joint customers that we have with AWS. We're also a part of the APN Global Starter Program, which affords us some exposure and a level of promotion that usually is not afforded for a company of our size. And we're also a part of the ACE program, which stands for AWS Customer Engagement Program. And that gives us the opportunity to collaborate with AWS sellers and unlocks a level of benefits that that enable us to offer things like free cloud credits to our customers that we have with AWS. And finally, we're listed in the AWS Marketplace for easy discoverability of our solution on Amazon Web Services. So with that, let me hand it over to Jobin to give us a overview of big data processing with EMR. Jobin?
Hey, thank you, Jason. Thank you for the introduction and details about the partnership. Really appreciate it. Good morning, everybody. Today, I will be taking you through a few of the benefits of using Amazon EMR with giving you or walking you through a bunch of benefits. I will not be able to go a lot deep, but I'll try to keep it as simple as possible and give you an overview of where we stand when it comes to data lakes and how EMR add value to that on AWS, and then a few of the benefits. Jason, could you just help me with going to the next slide? Yeah. So just to begin with an introduction, right? Today, if you look at customer needs or use cases, it is constantly changing, right? The use cases you had like 6 months ago or a year ago will not be the same use cases you are going to have today. Customers have different types of analytics to do comparing to like a few years ago. It could be just batch analytics and generating some dashboards, maybe like real-time analytics and alerting, predictive or machine learning use cases, image recognition, voice, and things like that. And the wide variety of data sets which are coming in would be different as well, right? It is no longer two-dimensional data coming in. It would be unstructured, and of course, the rate at which it is coming in would be completely different from what you would anticipate. And again, the need of that particular adapting to the needs are going to be challenging when you are restricted to a rigid set of infrastructure where you will not be able to grow, and if you have to or if you can, it would take time for you to grow as well, right? Let's just take a simple example. Any moving metal today have a sensor attached to it, and it is continuously emitting data, right? So when it is emitting data, what happens is you can capture it, you can ignore it. If you capture it, what on the good side, you will be able to get benefit of taking that data back to your analytics platform and looking at it, and it will help you to drive your business in a way that where to fix some of your issues you have versus where you can grow and where the demand is so that you can invest in that particular section. So today we have new generation security cameras and smart doorbells where you have it installed in your home. It is continuously emitting data, right? So you have different types of analytics which we have mentioned here. Of course, it has to detect motion, and then there are devices which will help you to detect voice, and it will tell you voice detected and just recording it. So it has that particular use case, and every now and then when smart devices with smart capability will help you to detect animals, detect packages, detect person, and a lot of computer vision involved in it, right? There are you have voice use cases, you have image recognition use cases, and then you use machine learning to adapt to the change. Hey, is this a package you have detected? Yes, and then use that to again remodel your data you have, and you should be alerted in real time. Real time in the sense within 1 or 2 seconds you'll have to be alerted when a person or an animal or something is detected there, or a motion is detected, so that you will get the alert in your smartphone, and then you can go from there. At the end of the week, end of the month, you may get a report that, hey, you know what, this is how your typical 1 month or 1 week of activity looks like. And then all of these use cases which I have mentioned here is imported into just one solution which a customer is using, right? So the type of data which we are getting, it's changing. The type of use cases we have, it is at an exponential rate, it is growing, and you can see for companies and for customers to adapt to that change, it is very tricky when it comes to you will not be foreseeing this, and there are going to be situations where customers will have a spike in this usage, and then there will be downtime as well. So these kind of flexibility and adaptability of the platform has to be there no matter what, to accommodate different variety of data, as well as to embark on different types of analytics which you would want to do, right? So starting from a gigabyte to petabyte to exabyte scale, and do that analytics in real time, as well as going way beyond and giving the customers the best possible satisfaction for your business. All these types of analytics has to be done no matter what. So that's just an overview of where we stand today in terms of the data growth and the changing dynamics of the analytics, and the use cases we see every now and then. Jason, could you move to the next one, please? Thank you. So as I was saying, building a data lake on AWS would be one of the solutions where you will be able to adapt to all these changes in a way it is very comprehensive, adhering or complying to our policies and security, which is embedded which comes as default with AWS, helps you to grow in a way that which suits your requirement. It's scalable and durable and cost effective at the same time, meaning which you would have lived different use cases, right? You have on-premises data, maybe two-dimensional relational data you have, which you would like to move into the data lake. That's something which on a day-to-day basis we see as a new use cases coming on board, different data sets to be moved for that, so that I can have a single data lake, and I should be able to, or as a customer, the customer should be able to look into the entire data set, and as required, he should be able to do analytics, machine learning, club and join different types of data sets, and make sure it will give them an overview of what's happening within their their stack, right? So this enables the customers to have an absolute view of their platform. In a way, it helps them to drive business value to what their initiative is really, and then focus on what would change their on the positive side, what would change their business, and direct them, giving them insights on what and where we should improve versus what new initiatives we can embark on, right? So these are just a few benefits of having data lakes and analytics on AWS. All right, so having this data lake in AWS, you can have Apache Hadoop, which is one of the common distributed processing platform we are familiar with, to run different variety of workloads, right? Starting from batch, which we are familiar with, Hive and Pig, scripting in a way SQLing the data, having the metadata created somewhere on the data which is residing, whether if it is two-dimensional or relational data or not. You can create and have batch jobs run on it, interactive Spark or Presto, real-time analytics using Spark streaming and machine learning, as well as NoSQL use cases. You should be able to use it. And the basic framework which is responsible for Hadoop, Yarn and HDFS are the latest, the Gen 2 version of Hadoop. They are the same exact open source version what we have in our platform, which will be helping you to plug onto your data lake on AWS, which would be sitting on Amazon S3. In that case, you will be able to interactively query a piece of data. You will be able to generate reports on top of that. You would be able to do a lot of processing, which you will be able to dynamically do and then move forward to adapt to a different set of use cases you come up with, your business requirements come up with, right? So it could be starting from simple log analytics through ETL, through real-time analytics and machine learning. Jason? Yeah, thank you. So this is a recent study for cloud and big data done by Forrester, and this particular comment was made. Public cloud for big data analytics is a future for the most companies. It's time to decide how far you will go and how fast. So depending upon the basic challenges, or standing within the basic challenges you see every day, you will not be able to go beyond what what the restrictions would be, right? You will be stuck onto a bunch of restrictions. With that restrictions, if you are on-prem, you will not be able to go a lot far. And I'll just walk you through what would be the advantages in the next slide. You can go from scaling up to any number of resources just like that with an enterprise easily manageable interface using Amazon EMR. So Amazon EMR provides managed Hadoop and Spark Cloud with 1/8 of the cost. So as you can see, we have, you may be familiar, we have nearly 20 Apache open source projects which are integrated and tested along with EMR packaged and delivered, so that you can have a different variety of use cases on top of it to make sure you are successful on AWS, right? So like I said, it's enterprise grade with support, easy button, it's not like you don't have to wait for professional services to come and install something for you. With a 1 or 2 button clicks, you will be able to set your cluster up and running, and then you will be able to ensure that, hey, at some point, if I don't want my cluster to be running or I want to scale down, that's possible. So next we will look at what are the major benefits when it comes to EMR, right? Automation being one of the important one. It's easy to provisioning, or the core node provisioning, cluster setup, Hadoop configurations, installing your applications, whether it's Hive, Spark, or Zeppelin, or Zookeeper, job submission, monitoring, and failure handling. Everything can be automated, and then you will be able to even use APIs to control those, right? So you don't have to even log into the cluster to submit the jobs, and you can have different types of way to submit jobs, and even you use it as a transient cluster to get the work done. And then it is of course decoupled, right? You can have you can have your storage, which is in S3, decoupled from the compute, which is running on EC2 instances, and then you can even have use cases of persistent cluster, which is running all the time, or transient clusters, which runs for the job, and then the cluster will be deleted after that's done. But still, you will have the persistent data sitting in S3, so you will be able to browse through it really quick. And then compute flexibility. It brings you flexibility in terms of choosing a wide variety of compute instances, M5 or M4 or C4 family, which is generic or compute or memory or storage optimized, and help you to move forward. Then of course elasticity, right, which is one of the biggest challenges our customers see in on-prem, where you will not be able to scale up, scale down, or auto scale to adjust to the demand, right? When you have a peak usage time, it should be able to automatically or manually scale up, and then scale down once that is done, so that you can save cost if you want to. And then auto scale based on the requirements and adapting to automatically to the requirements. You can spin up the cluster and then bring back, right? Then next benefit is integration, right? Integration with existing AWS services, Kinesis, DynamoDB, Amazon EMR can interact with S3 using EMRFS, KMS for encryption, Redshift through Redshift Spark connector, etc., etc. So many use cases you would see around to interact with different variety of AWS services outside of EMR, and then have a consolidated view if you want to go through with it. And then of course the last one which I would like to cover here is the current, which means just to bring up a point, it is pretty consistent that we go ahead and make sure that the versions are not lagging far behind our Apache version, so that the EMR ensures that we use Apache BigTop software, which helps you to a package and make sure the testing and everything is done properly, so that we can release it as soon as possible. The Apache version is released, so that we are pretty much tied towards what the latest and greatest versions of Apache software is available with support out there. Like I said, this is not just the benefits; these are some of the important benefits, I would say. And then, as you can see, these are some of the customers who are who are using our EMR powers most of the most of these customers' use cases, so that it helps them to grow and make sure that their platform meets the requirement what they need and the use cases what they have. With this, I'll stop here, and I'll pass the baton back to Jason to take you through the benefits of cost management with Unravel.
Excellent. Thank you, gentlemen. Now we're going to move into really a discussion around effective cost management for Amazon EMR. And before we really get into it, I'd like to cover really why Unravel and exactly what our technology does. So you can see that Unravel is effectively a big data performance management solution, and also helps you optimize costs for your big data on systems like Amazon EMR. We have broad technology and platform coverage. So we cover the entirety of the full stack of big data ecosystems. So open source projects like Spark, like Hadoop, Kafka, etc. We've been supporting those on premises and in the cloud for years, as well as we are multi-cloud and hybrid. So we support all of the hyperscale cloud offerings out there, including Amazon EMR and Amazon itself. And in addition to that, we have strong market validation with about 15,000 nodes under management across mostly financial services, but we also have many customers in healthcare as well as retail who depend on us every day for proper data management. And we're also supported by an experienced team of big data experts from companies like Cloudera and Hortonworks, as well as academia. In fact, our chief technology officer is a tenured professor at Duke University. So we have a ton of experience behind us. So many of you know that data operations are really the key and the heart of what Unravel does. And what we've seen in recent weeks, just all the current events happenings that are happening right now, that data ops are more critical than ever before. And I'll just cover a couple anecdotes that our customers have shared with us as the consequences of this SLAs. We have a ton of banking customers, and with the announcement of the stimulus packages that are happening around the globe, unfortunately, there's a lot of fraud that's happening around the world. And as those fraudulent transactions increase, oftentimes big data is dependent on to find those anomalies and to detect those fraudulent transactions, so that a bank can take actions on it. And the consequences of not having proper remediation for this SLAs really leads to millions in theft and fines, and that's goes way beyond just the costs go way beyond just the compute and storage in terms of what improper data operations can cost you. And similarly with healthcare, as many of you know that just in reading the news every day, there's a healthcare crisis that's happening right now, and many of our customers, even before the crisis, depended on their big data systems for things like patient profiling, where they really depend on those systems to triage patients for things like sepsis and meningitis. They're using those same systems for triaging patients for the current health crisis. And without properly scalable and proper data operations, you're going to lead to poor allocation or misallocation of resources, which could be disastrous. Right? So at the end of the day, this is what Unravel does. We've helped not only healthcare organizations, but all organizations really uncover huge savings in their data operations cost. And our aim is to drive efficiency for their use of big data. So specifically, let's get back to specifically what we're talking about for Amazon EMR. Why Unravel for Amazon EMR? Well, we have really 3 core points of value that really enables our customers to choose Unravel. The first one is managing cost. So our customers have realized the benefits of fine-grained visibility, getting to the job or the user level, and for instance, finding the right cloud instances that will alleviate you from having to pay too much for your EMR instance. You can cut costs by 30 to 50% on average. So that's a benefit that our customers have learned to heavily lean on. The second point is to manage performance on a day-to-day basis, which increases productivity. So one of the pain points of managing an EMR cluster is the difficulty our customers face in quickly diagnosing issues and resolving and stabilizing their system so that they can spin up new use cases or handle scalability demands, as I've talked about in the previous slide. So using Unravel for Amazon EMR, our customers are able to free up 50% or more of wasted time just sifting through logs and trying to triage issues that they may have in their system. And the third point of value is really around migrating intelligently, not just a simple lift and shift, which could be inefficient, but because we have so much expertise in big data on premises, that we're able to map your on-premises Hadoop inventory and tell you what class of applications you have, some of the hotspots that you maybe want to be aware of. And we're able to provide that GPS level mapping of your migration to the cloud, which really our customers find very valuable. Okay, so let's take a step back for a second and talk about the entirety of the cost of a big data system, the total cost of ownership. And according to a recent IDC report, which speaks about the migration benefits of moving Apache Spark and Hadoop to the cloud, it noted that about more than half of the total cost of ownership of a big data system is due to IT staff or productivity costs versus your traditional infrastructure and software costs. Right? So going beyond just compute networking and storage, what our customers have found, and which is very in sync with this report, is that there are a number of productivity costs that hinder or contribute to the overall cost of a big data system. So the 5 top productivity costs that we've uncovered are the following. Number 1, poorly performing or failed jobs. So you know that if you manage an AWS EMR system, you have to manage hundreds, if not thousands of jobs at a time trying to complete a task. And it could quickly become untenable when you have that many jobs and trying to monitor that many resources. So that's something that could hinder and contribute to the productivity costs. The second one is really around finding root cause analysis, getting to that root cause in an efficient, timely manner is another huge source of productivity cost. The third one is missed service level agreements, and not just missed windows of opportunity, but just financial penalties that our customers may have to incur as a result of missing SLAs for their customers. The next one is around the DevOps and IT ops blame game, as we call it. So we have application developers and IT infrastructure developers kind of pointing the finger at each other, saying, "We're not sure exactly what the issue is, why this job failed, but we think it's a cluster." And the IT ops pointing the finger back to the application developers, saying, "No, it's inefficient code. You may have SQL that is just not written properly or inefficient that is causing this job to fail." And finally, chargeback, showback situations where productivity costs are increased, or you're not able to drive accountability to a certain individual or a certain department that's consuming a lot of the resources for the cluster. So those are the top 5 productivity costs that we've seen in our customer base. Okay, so the remedy to that, as well as the infrastructure costs that go along with that, is you could do this manually, right? So you could decide to size your EC2 instances and your topology in a manual fashion, or play around with the different configurations and different profiles of storage in S3 that get you to an optimized state. But that could incur a lot of trial and error work and waste a lot of time in the process. So we've seen customers do this prior to having Unravel and run into many different situations where they may be able to do it on a temporary basis, but as their infrastructure and their system requirements change, they're not able to respond in time or in an efficient manner using native tooling like CloudWatch or the different open source tools out there. So the Unravel solution is that we'd like to make everyone on your team a data expert and self-sufficient one at that. And we do this in 3 ways. So we provide a unified view that gives you an end-to-end view of your data pipelines in a single pane of glass. So whether you have Hive jobs, you have old MapReduce jobs, or Spark jobs in different clouds, you're able to manage all of that in a single unified view. Now, this is powered by an AI-powered, AI-backed engine that provides insights and recommendations to tell you exactly what you should do with your cluster configurations, with your resource management, the different types of EC2 instances that you should be running for optimal performance of your EMR jobs. And finally, we're able to surface all of those insights and recommendations in a variety of ways, including automated remediation that allows you to repeatedly tune your system in a self-sufficient manner without you having to constantly manage that system on an ongoing basis. So these are the 3 points that hopefully will enable your team to be a data expert and self-sufficient. And this is really enabled by our extensible data operations platform. So I mentioned earlier that we do cover the entire full stack. So all of the open source projects out there, like a Spark or Hadoop or Kafka, we also cover their equivalents in cloud native fashion. So things like Azure Databricks or Amazon Redshift or Amazon EMR, of course. And we are multi-cloud and also hybrid. So if you choose to go on premises or in the cloud, you're able to experience the same console and the same single pane of glass for your data operations. So all of the metadata, the operational metadata that's generated from these systems are collected by what we call the adaptive data collection facility. And it's really a series of lightweight sensors that we have in the Unravel platform that allows us to pull and aggregate all that information into a single context, whether that be a job, whether that be an application or a user. We're able to give you insights and recommendations on the configuration parameters that you should be using to make your jobs run most efficiently. And again, those insights and recommendations are surfaced in a variety of ways, including reports, perhaps alerts in something like ServiceNow or PagerDuty, or you're able to have that in a automated fashion through auto actions and alleviate you from having to continually manage the system all the time. So a quick view into the total cost of ownership illustration in a life with and without Unravel. So this is a typical illustration of customers that realize the benefits of using Unravel on Amazon EMR. So for a typical issue, you're able to get to the root cause of an issue in minutes with Unravel versus days or perhaps weeks without Unravel. So to triage an issue in a typical big data system, you have to sift through a number of pages of logs and try to correlate that information yourself. And what we do is we simply automate all of that for you so that you don't need to reinvent the wheel from scratch every time. And in terms of cost and labor savings, it's pretty apparent that our customers have realized huge savings in infrastructure, both in storage and compute. Around 50% is kind of what we've seen, and labor savings as well. You could really cut down on the amount of expertise that you have on hand for maintaining your big data systems in Amazon EMR, both in terms of big data engineers and developers for your applications. Okay, so with that, I'm going to hand it over to Scott to show you an illustration of what our products can do for cost management in Amazon EMR. So let me go ahead and give Scott the presenter rights. Okay, Scott, there you go. I see your screen.
Yes, great. Thank you, Jason. So I am in the user interface within Unravel, and our user interface basically provides visibility for the operations folks who manage the EMR clusters to be able to get insights into how the clusters are being utilized, get alerted when jobs are not meeting SLAs, when some rogue application is using more than its fair share of resources. And the other part of the solution is the application part, which is providing visibility into each individual user's workloads, being able to identify when those workloads have areas of improvement where they can be tuned to reduce the amount of resources, and also have the jobs run faster. So this can potentially save you money, because if you're using transient clusters, you can run your jobs faster and then stop those clusters quicker. And so I'm going to first focus on the operational side. I'm going to spend a little bit of time on operations, and then I'm going to talk a little bit about how an individual user can have a self-service interface into seeing their jobs and figuring out why their jobs have failed, why their jobs are running slow, and how can I optimize those jobs. So first of all, we provide an operational dashboard that allows you to monitor all of the EMR clusters within your environment, or an individual cluster. And our solution works with transient clusters or long-lived clusters, whether they're single-tenant or multi-tenant clusters. And for a given cluster or groups of clusters, we monitor the amount of vCores that are available and being allocated for the Spark and, for example, Hive jobs that are running on those clusters. And we can see when we're basically redlining, either from a CPU standpoint or from a memory standpoint, which is an indication that you might need to increase or decrease the number of instances for your worker nodes, or maybe change the type of worker nodes you have based on the workload characteristics. Now, one of the things that we do that's very unique is that we gather data from various APIs, such as the Yarn Resource Manager. We also get information from log files, such as the Spark event logs. And we also have our own sensor data, which monitors the sensor, basically resource consumption within each individual container that is running your workload. And we take this data and we run it through a machine learning pattern, and we look for inefficiencies. And we can detect when there are Spark events where there's inefficiencies, such as too few of partitions, or underutilization of storage, or memory utilization issues. And so we detect all of the applications that these events are occurring, and then you can drill down and you can actually go and potentially tune these applications. And then if you tune them, they can basically run faster, use less resources. So the other part of this is being able to go a step further. And let's say that you might be interested in workloads for a particular department, and you want to understand for a particular period of time, what are the, what is the jobs that are taking the most amount of resources from a CPU or memory standpoint. So you can drill down, and this is a demo environment, so we don't have a lot of applications running, but in most environments you might have hundreds or dozens of applications running. And what we do that's very unique is we're able to show you resource consumption for one specific EMR cluster or all your EMR clusters, and see which jobs are running at that time, which jobs are taking the most amount of memory and vCores, as well as if there are other jobs that are stuck in pending state because the queue that the job is scheduled to run on doesn't have resources allocated. So from an operation standpoint, you can quickly see, who are the hogs that are taking the most resources, and are there any jobs that are impacted by those hogs? And also, are those hogs potentially tunable, which we detect with a little wrench and screwdriver, which means that there's a potential tuning recommendation for that job. We also have chargeback capabilities, which allows us to understand for a given EMR cluster or group of clusters, which department, which user, which application is using the most amount of CPU or memory. Now, that in itself is pretty powerful, especially if you have transient clusters that only are running for a day or two, and we keep this history over time. It can be somewhat problematic to be able to do a usage report of transient clusters that are going up and down hundreds of times in a given quarter, or much less a year. We keep all this data historically for up to a year, or it's configurable, and we're able to quickly understand which particular department, for example, is using the most resources, and then also which, for operations, what type of workloads are they running? Are they running Hive on MapReduce? Are they running Spark? And then what are the actual users that are running those jobs? And then get a list of the actual jobs that are running for a particular user, for a particular queue. And we can also take this information, export it to a CSV file, which then can be used for doing executive level chargeback reporting, which some of my customers use this for. In addition to that, we also provide very good graphical visualization, such as this heat map, in understanding how one or many clusters are being utilized within a 24-hour, within 7 days a week, 1 hour time slots. When is the environment the most busy from a memory standpoint or from a vCore standpoint? And so it allows you to understand, how utilized are my clusters, and when are they most utilized? Are they most utilized on Tuesdays mornings or Friday afternoons? So you can figure out when is the appropriate times to maybe spin down or spin up your clusters. So it gives you some understanding of how the cluster is being utilized. The other part of this, so that's the operations part, and I'm touching on a couple of things, but on the application side, what we're providing is the end user a self-service way of looking at their workloads for a given period of time, filtering by the type of application, the status of the application, maybe even by business tags, such as what project that job was associated with, or the cluster that it ran on. And we can quickly at a glance see all of the jobs that user ran, the status of those jobs. Are they running? Are they completed successfully? Did they fail? Also, we can see if a job violated a policy, like it didn't meet an SLA that you defined, or maybe that job has some tuning suggestions based on the metrics that we've collected. We see inefficiency. So from here, you can actually drill down on a given Spark, for example, Spark application, and in this Spark application ran for 6 minutes. We can see all of the jobs associated with this Spark application. We can see which job took the majority of its time. We can drill down on the stage. We can even look at the timelines so to understand all of the tasks that were executed and which executors and what host they ran on. So imagine if you had hundreds or thousands of tasks running. It would be helpful to understand which tasks are running slow, which tasks are running fast. Is there data skew? We provide that type of visibility. to figure out if the application is running optimally. We also do some interesting things where you can actually see the call site number, which allows us to understand, okay, this application took 6 minutes, of which 5.5 minutes was spent on this one job, and this is the basically the Scala. This is the line of code in the Scala application where it basically is spending this 5.5 minutes. The other thing that we do that's pretty unique is like if you wanted to know how much memory you allocated for this job, so you could go into your configuration. You could say, okay, my executor is set up to have 3 gigs of memory. My driver is set up to have 1 gig of memory. I can then use our sensor technology, which is the sensor that's monitoring every single driver executor within the container. And I can actually not just see what was actually allocated, I can actually see what was being used. So I can see if there's any inefficiencies that occurred. And part of what we do is we analyze this metrics, the configuration settings and the sensor data, and then we can then provide actionable tuning recommendations. So we actually provide Spark dot settings that you currently have set and what we recommend based on the metrics that we collect. And by applying these parameters, the next time you run, they will then allow the job to run faster and use less resources. In addition to this, we provide, I kind of think of it like cliff notes around the behaviors that we're seeing with this application, using too much memory, not using enough wasting CPU resources, and so on. So we provide explanations of what we are observing, like low memory utilization, low CPU utilization, and we provide, in some cases, actionable recommendations on how to improve and eliminate those problems. In addition to tuning, let's talk about root cause analysis, because this also falls in line with cost. Because if you run a job for an hour or two and it fails and you have to rerun it, that's longer that you have to run your EMR cluster. So you want your end user to be self-sufficient, be able to figure out how to troubleshoot their own jobs on their own without relying on a subject matter expert, which is in most organizations is hard to come by. So what we're able to do is we can quickly, when we see a job failed, we can go to application failure, and we basically analyze. We scrape the logs. We look at Yarn Resource Manager. We look at other metrics, things that would take potentially hours or days to sift through. That's even if you could get access to all this information. And that's one of the challenges, is the information is not all readily available, and depending on your company's policies, your end users might not have access to this information. So what we're doing is we're pulling all this information into a single place, so you have a single pane of view, and we're able to then analyze it and quickly see, okay, this application failed because of an out of memory issue. And we also provide the error messages that occurred that are coming from Yarn Resource Manager to see kind of what are the fatal errors. We see the stack error messages. And in addition to that, we also can look for any of the interesting driver executor logs. So if I want to then look at the raw logs and look at the raw error messages or warnings that occur, I can pull that up. So we're actually grabbing this information and we're storing it historically, for even for transient applications. So if you had a transient EMR cluster that ran a job, it failed, the transient cluster's gone, it can potentially be difficult to go back and figure out what happened because that cluster is no longer there. But we keep the logs of the interesting logs. We grab the parts of the logs that have the errors and the warnings, and then you can scroll through here and look at that to see what happened. So it's very useful for doing root cause analysis. And let me see here. So I think that covers what I wanted to cover. I also wanted to mention not just Spark. I mean, most people are using Spark on EMR, but there are still customers that are heavily using Hive on MapReduce, for example, or Hive on Tez, which we fully support. And we're able to look at the query. We're able to see what tables are accessed. We're even able to provide recommendations, just like for Spark, where we look at all the metrics that we collect for that Spark application, and we provide parameters that you can change to speed up the Hive query so that it runs faster and uses less resources. So at this point, I'm going to stop and hand it back to Jason.
Great, thanks, Scott. Can you hear me okay? Okay, great.
Yes.
Yeah, thanks for that great demonstration. Went into a lot of detail about cost-saving techniques on Amazon EMR. So I wanted to spend just a couple minutes on the current customer offers that we have out there with AWS. So as part of, as I mentioned in the beginning, as part of being in the Global Startup Program as well as the AWS Customer Engagement Program, we're granted, we have access to a lot of benefits in terms of free credits, free cloud credits for AWS trials. So right now, just for simply trying our EMR product on the AWS Marketplace, you'll be granted $2,000 in cloud credits just simply for signing up, right? No obligation to purchase, just experience the product and see if it works for your organization. And if you're interested in a what we call rapid POC, and this is a guided install virtually that we can go through without anybody on site, we can give you in excess of $10,000 in AWS credits for a proof of concept of that nature. So please feel free to contact or reach out to me. I'll have an email right after this slide. And there's a screenshot of our AWS Marketplace experience on the right-hand side. Okay, so if you're interested in any of those offers, please reach out to us at Unravel, and that's hello@unraveldata.com. And we'll be happy to walk you through the product in a demo or actually help you install it, Unravel, on your EMR environment. So with that, let me go to some of the questions that we have. So we just have a couple questions here. So the first question is, does Unravel support Spark streaming? And Scott, maybe you can help me answer that one.
Yes, so absolutely. I did not demonstrate it, but we fully support Spark streaming on 1.x or 2.x Spark, structured Spark streaming. And we're able to show the micro batches. We're able to see if there's an issue with latency, either coming from the Kafka side or if it's coming on the Spark side, not being able to process the Kafka data quick enough. And we actually provide some tuning recommendations specifically for Spark streaming.
Great, thanks, Scott. Next question we have is, does Unravel support monitoring ephemeral EMR clusters?
Yeah, I mentioned that. So basically, the way our technology works is you have to add Unravel to your Bootstrap script. So when you spin up an EMR cluster, it will execute our Bootstrap script to load our agent on the master node, as well as set up the sensors so that when you run your Spark or Hive applications, our sensors also get loaded, and we then monitor the resources consumed by those Hive and Spark applications. And then from there, that information gets sent to the UI, which you then see, which I showed.
Thanks, Scott. There's one more question that came in. Does Unravel support Apache Airflow?
Airflow. I do not believe we support Airflow. Airflow. We support Airflow is not the scheduler. Maybe it is. Airflow. If Airflow is the scheduler, we support Uzi, and I think we support Airflow for scheduling. If Airflow is the scheduler, and it depends on the specific version. So I'll have to look into that, but I think Airflow is the scheduler.
Okay. Yeah, we can get back
to. Yeah, we
to,
support. We do. The answer is yes. Okay. It depends on the specific version of Airflow. We don't support all versions of Airflow, but we support the latest versions.
Great. I don't see any other questions in the question panel.
We can give folks another minute or two. If they do have a question, please go ahead and use the GoToWebinar control panel. And if we get any more in the next minute or two, we'll go ahead and answer them. But meanwhile, Jason, I can go ahead and do the drawing for the two $50 Amazon gift cards while we're waiting.
Yep. Yeah,
So
we can go ahead and do that.
Okay, great, great. So today's two winners are, first winner is Rose C. Congratulations, Rose. And our second winner is Jen F. Congratulations to both of you. We will be sending you an email following today's webinar to get your information, get your Amazon gift card over to you via email. So please look in your email for a message from us. Doesn't look like we've gotten any more questions in, so I guess we'll go ahead and close out the question and answer period. You cool with that?
Yeah, yeah. Just wanted to just in closing thank Scott and Jobin from AWS. I really appreciate the collaboration and the partnership here. And thanks everyone for attending our webinar. And I'll hand it over to Charlene.
All right, great. Thanks so much. I do want to remind the audience real quick that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We are going to be sending out an email this afternoon that contains a link to access the webinar on demand. And we are also, the webinar is also going to be living on the devops.com website. So you can always find it there. Just go to devops.com/webinars, look in the on demand section, and it should be right there waiting for you. Yes, I do want to thank Jason, Jobin, and Scott for a great presentation. Gentlemen, thank you so much for your time. And I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing out. Have a great day, everybody.